Hi, this lesson is from page 659 in your student book, and the objective is the student will be able to find the probability of a dependent event and a disjoint event. The essential question is, what steps then do you take to find the probability of dependent events? So think about two examples. You're excited to go to some event or to your friend's house or something you're excited for. And if you can just ride your bike there by yourself, that would be you're independent. You can just go whenever you're ready. However, if you're dependent upon somebody else to get ready at the same time, or maybe dependent on somebody else to drive you there, think of that as how you're dependent. One person's actions affect the other. It's same in probability. There are some probabilities where they just stand alone, and then there are some probabilities where something is affected by another, whether it's you're not replacing a marble or not replacing a card, and then that would be dependent. So the vocabulary words, compound event has two or more simple events, and an independent is when the outcome is not affected by something else. All right, so you can find the probability of two independent events by multiplying the probability of one event by the probability of the second event. So notice this is an independent example because whatever you roll on a number cube, which is a dice, whatever you roll on that is not affected at all on if you get heads or tails. So it's independent because the cube cannot affect the coin toss. So the first one is, what are your probability of getting evens? Well, on a dice, that would be the 2, 4, and 6. And 2, 4, and 6 are three different outcomes out of the 6 sides of a dice, 1 through 6. So you would say half of them on the dice are even. That's its own probability. And then here, the probability of tails, heads or tails on a dice, the probability of getting tails is 1 out of 2 chances you'll get tails. Then to find the probability of those two both happening as one combination, a 2 with tails, a 4 with tails, or a 6 with tails, you would multiply the numerators, multiply the denominators, and you would get 1/4. Here, the probability of getting a green marble, as you can tell, there are 2 green marbles out of 8. And notice the marbles are not affected by the tiles, the numbered tiles. So you would just say 2 are green out of 8 in all, and then reduce that to 1/4. The probability of getting an odd tile, there's 1 and 3 are both odds. So 2 out of 4 are odd, and then reduce that to 1/2. And then down here, you would just multiply those two independent probabilities. And so you would have the green times the outcome of an odd is 1 out of 8 chances that you'll get a green and an odd in the same combination. All right, the probability of drawing a girl's name. Notice there are 14 girls out of 35 people in all, and then reduce it. The probability of drawing a pet cat, maybe you're just drawing the cat out of a bag, the name. You'd say there are 12 cats out of 28 pets, and reduce that to 3/7. And those two are independent. Whatever happens when you're drawing a girl's name out of a hat does not affect whatever outcome you have of getting a cat over a dog in the probability. But the combination of getting both at the same time is 2/5 times 3/7, and then you would get 6 chances out of 35 in all of getting a girl and a cat. All right, dependent events are when the outcome of one does affect the outcome of the other event. Very similar, you'll still find the two separate probabilities, but the second probability will change. More than likely, you'll reduce the denominator by 1 because, for example, you won't return the marble to the set. So then you have 1 less marble the second time around, and then you'll multiply. So what's the probability of choosing a red and then a yellow when we have all of the marbles in a bag? And then notice we're not replacing the first marble the second time. So in a bag we have 6 green, 4 red, 2 blue, and 5 yellow. So when you see it written like this, especially with that comma in the middle, you're thinking it's 2 turns, not in 1 turn, in 2 turns. So you would say, how many red? 4 out of how many in all? 17. And then consider that to get the yellow marble, there are only 16 marbles left in the bag. You didn't put that first marble back. And so then you would say, here we go, let me just quick do the multiplication sign. Then you would say, the second time there are 5 yellows out of now we only have 16 left. So you're assuming that the first time you did get the red. So how many yellows left out of 16 in all? And again, here we could crisscross reduce. How many 4s in a 4? 1. How many 4s in 16? 4. And then when you multiply, you get 5 chances out of 68 of getting red on the first draw, not replacing it back, and getting yellow the second time. All right, a disjoint event is when 2 events cannot happen at the same time, but they both are favorable outcomes. So on a number cube, what is the probability of either getting an even or a 5? Well, obviously a 5 isn't even, so they couldn't happen at the same time, but you're going to say any of the evens would help me win a game, or if I get a 5, I would win. And so you would say, my favorable outcomes are all the even sides of a dice and a 5. So I have 4 favorable outcomes out of 6. So I have 2/3 of a chance of getting either an even or a 5 together. All right, I know that was quite a bit of different concepts to throw at you, and I will review it in class. Hold on to your questions, and great job persevering in the notes. Have a great day.